All right, trying to get you towards vectors a little bit. I don't have a lot of experience with them. I wish I had more. Wish I could chime in a little bit more, but if you encounter them, physics class, then at least we hopefully will make some progress on the math. All right, so I'm calling, I'd like you to draw angle A. You see everything here? Yep, so angle A is always going to be at the origin. And we're just going to draw, oops, I don't think that's dark enough. Good enough, all right, so I'm giving you a 53-degree angle, so something like that, pointing off in that direction. And I'm gonna say the radius is, let's just start with a 10, nice, easy number. Let's say the radius is 10 units long, so that means this is 10. And it's got 2 components to it, a horizontal and a vertical. And we're trying to find this distance X. And we've been given a, I don't know, what did I say, 53-degree angle? All right. Well, you're trying to put your trigonometric concepts together. Angle to ratio. Angle to ratio. That's all we do, trig, or ratio to angle. Well, I'm seeing an angle and I'm seeing a ratio. I'm seeing two ratios. I'm seeing 10 over X and I'm seeing X over 10. I'm going to work with X over 10. And I hope that you can look at that and say, well, what's the name of that ratio? Well, that's with respect to this angle, adjacent over hypotenuse. Adjacent over hypotenuse is the cosine ratio. The cosine ratio of 53 degrees is X over 10. Therefore, this is 10 times the cosine of 53 degrees. And Y? Well, that's not the cosine anymore. That's the sine ratio. So that Y value is 10 times the sine of 53 degrees. And of course, that's a coordinate. So that X and that Y could have been written as 10 times the sine of 53, and that X could have been written as 10 times the cosine of 53 degrees. All right, so magnitude and direction. Magnitude, direction. All right, you're going to study that in physics as to how to apply it. So I got a 110-degree angle. 110 is probably in that direction. Right, and I'm looking at, I erased everything. All right, so let's say a radius of this time, last time it was 10. Let's make it 50 this time. All right, so there's your 110. And that gives us a reference angle, which we don't even care about right now. That's a Y value, that's an X value. And I said that the radius was 50. So what's this coordinate? Maybe you can even tell me right now. It's 50 times the cosine of 110 degrees. Is that what I said? Yeah, 110 degrees. And the Y value is 50 times the sine of 110 degrees. Why? Because X over 50 is the cosine ratio. And I get that drawing when I have 110 degrees. I hope you can see the, oops, sorry, X over 50. I hope you can see the movement of the 50 in the multiplication position, getting us that answer. And all I'm doing is changing to Y over 50, and that's opposite. So that's going to change the mathematical operation to the sine of 110 degrees. And that's a coordinate in the trigonometric coordinate system. All right, so now I'm going to go 321 degrees. 321 degrees is, I don't know, maybe there-ish, somewhere there-ish, with a radius of, how about we just use 7? All right, so that's 7 units long. So there's a Y value. We're doing 321 degrees. And that's going to get us Y over 7, which is the sine. The sine of 321, this drawing, is Y over 7. Okay, so I think we can see that Y value is 7 times the sine of 32. 320, sorry, 321. There we go. It's getting late here. I'm trying to finish before the next class. And do I have to even look at this one? Can you say 7 cosine of 321? Geez, it'd be nice if you could, right? Because this is the cosine ratio, X over 7. I'll do it here. X over 7 is the cosine, not the sine ratio. And I hope you can certainly see that movement of the 7. All right, 47-degree triangle, back to the first quadrant. And I'm writing, little z, so I'm trying to write triangles in the X, Y, Z format. Maybe I should go to a textbook and see if that's how it's done more often there, but I don't want to write little x because I don't want any confusion about angle and ratios. So I'm calling that angle A, and I'll try to do that each and every time for this topic. All right. So now we got a 47-degree angle. All right, so there's 47 degrees. We got a radius. How about we get a radius of 1003? Long critter, but that's 1003. We got a y component. We got an x component. I can see the x over 1003 is certainly a cosine of 47-degree ratio, and I can see that the opposite over the hypotenuse is a sine ratio. I need an angle with that language, and that angle is 47 degrees. Oh, good. All right. So it looks like I just got to multiply that one by 1,000 to get that location on the graph. And this one over here, it looks like I just got to move the 1003 to this side. And I got the cosine of 47 degrees. And remember, that's 1003 times the cosine of 47. Let's do a little arc cosine. 47 degrees here. Right, there's the arc. What's that height? 47 degrees, pretty damn close to, excuse my French, root 2 over 2. Right, so 47 is farther up, so the width is a little bit less, a little bit smaller than 0.71. So 7/10 of this is around 700 for a length, and hopefully that drawing, I don't think it's drawn too well to scale. That looks like a 60, more like a 60, somewhere closer to 60 than 47. 47 would have split it in half, almost split it in half, so probably that. So I'm hoping that X looks more to be in the 700 range, 1003. Hopefully that makes sense to you. All right, one last one, then I'll upload this video. Maybe you can just write the coordinates. Given the fact you've had 4 practices, 200 degrees, 180 is here, so 200 might be there. So that's got a component, a y component. It's got an x component. Let's put the x here, and let's put what that is. Let's put the y there, and let's make the radius. I don't know, what do you want the radius to be? How about 17? All right, so that's 17, and I got a 200-degree angle. So what is this coordinate? What is that x, and what is that y? Well, that x is the cosine of 200 degrees, I think I said. So the cosine of 200 degrees looks like it's going to get us, I don't know, that's the same as 160 over here. And I went another 20, so back 20. So 160, boom. So it's near maybe negative point, geez, I don't know, negative 0.9, I don't know. Anyway, I'm going to multiply that times 17. That's my x coordinate in the trigonometric coordinate system. And the y is simply 17 times the sine of 200. And I got done before my next class came in. So I'm going to push end the video. I'm going to upload it and I'm going to post it, and maybe it'll help you. Hope so. Hope you're looking at these.